The essential question: what information does a chemical equation contain? To start off with, chemical equations contain reactants on the left and products on the right. This is just like a math equation. Here we have carbon plus oxygen. Yields is how we say this right here. This would be your equal sign in math. Carbon dioxide. So reactants, yield, products. When we write chemical equations, the standard format for writing elements is that the first letter of the element is a capital letter, and the second letter is always lowercase. So Na is sodium. Remember, it's a Latin word. Cl, this is not Ci, this is Cl, which stands for chlorine. So this is sodium chloride, which is table salt. If we wrote it with all capital letters here, it would mean something different. This would be nitrogen, this would be carbon. We would not be able to tell this was Na and Cl. This looks like 4 different elements. Because remember, some of the elements have 1 letter in their symbol and some have 2. When we write these chemical symbols for molecules, we use a subscript to tell how many atoms are in the molecule. So this right here is the symbol for water, H2O. The 2 means there are 2 hydrogens, so it's always small and written on the bottom, not on the top, like you do usually in math. Okay, but this one's down on the bottom. So that means 2 hydrogens, 1 oxygen. So 2 hydrogens, 1 oxygen. This is our little Mickey Mouse water molecule. If there's only 1 of the atom, then we don't need to write a 1 here. We just assume there's only 1 if we don't see any sort of subscript. Coefficients. We use coefficients in front of an entire molecule in order to show how many of the molecules there are. Okay, so the subscript told us there were 2 hydrogens in our water molecule, 2 hydrogens. But now the coefficient, which is a large number written at the beginning of the molecule, tells us there are 2 molecules. So the subscript tells us how many of each element are in the molecule, and the coefficient tells us how many total molecules we have. And finally, the law of conservation of mass. This is a definition that you should know. The law of conservation of mass states that atoms are not created or destroyed in a chemical reaction. So, for example, going back to our original equation, carbon plus oxygen yields carbon dioxide. We have a carbon here, an O2 molecule, that's an oxygen molecule. Here's our oxygen molecule over here. We aren't actually creating new things or destroying the elements during the reaction. We're just rearranging them. They're like Legos. So if you think of these as little Lego pieces, we can pull them apart and make new things out of them, but the Legos stay in one piece.